Welcome back, everybody. So we'll go ahead and get started with our afternoon session. Our first talk is going to be led by Skeeter, who's going to be going over new and fun ways to process EddyPro data.
All right, good afternoon, everyone. I'll try to keep this short. It's more of an elevator pitch than anything. I don't have nice figures and stuff to show. But especially given what was talked about this morning, I feel like what I have to say might be of interest to some people. So I've been working on some ways to improve the experience of working with EddyPro. It's great for a lot of things, but it can also be a bit clunky to use. Right? So it's one of the most popular eddy covariance data processing packages. So it was designed by Lycor to provide easy, quotation marks, accurate flux computations. So it uses a graphic user interface to facilitate interacting with the process pipeline that's actually executed in Fortran. And so, based on the results of the survey that you all filled out, of the 35 people, so I think we had 44 respondents in total, but of the 35 who listed something other than a blank, 26 people in some way, shape, or form use EddyPro, whether that's standalone or in combination with their own in-house processing. So it's about 74% people use EddyPro. Right? So EddyPro is great for some things. The GUI makes Flux processing accessible. You can point and click without any need for coding experience, particularly useful if you're, say, trying to get students involved in the process or something like that. Users can see the wide range of options available, and EddyPro has pretty well fleshed out documentation. I like how if you hover over the little question marks, they give you a link to the relevant documentation for the different processing methods. So if you've got like a single season of eddy covariance data to process 3 months or something, EddyPro is going to work great for you. The drawbacks are when you get to processing large volumes of data, right? So the point and click procedures become a bottleneck when you're dealing with multiple site years of data, multiple sites worth of data, new runs have to be initiated each time data comes in. So if you're dealing with a site that's online and you're getting data, new pull data every month or something like that, somebody has to go around and process that data. Because of the point and click procedures, there's ample room for error, particularly when it's, say, conducted by more inexperienced users. A lot of times the PI might push the workload of processing their high frequency data off onto, say, research assistant. Very easy to totally unintentionally click the wrong button, right? So this point and click processing bottleneck leads to delays in processing of high frequency data. On top of that, long runs, even without error, can take an inordinate amount of time to process, and this may lead people to avoid testing alternative methods. One of the speakers before lunch mentioned that, some of the spectral corrections might need an additional adjustment, right? If you got to go back and reprocess a whole bunch of data that you've already done, maybe you're going to avoid that. People are going to avoid testing alternate methods or recalculation of fluxes, even when perhaps it's necessary, right? So what can we do to make that a little bit easier, a little bit less painful? So I've been working on an API or application program interface that can both automate and parallelize flux processing in EddyPro. So it can be called from command line, a Python script, or run semi-interactively in a Jupyter notebook. If you run it from command line or a script, you can, say, schedule runs at regular intervals as new data comes in, or set up multiple runs if you want to compare different spectral correction methods, for instance. Additionally, the API can process longer runs in parallel batches to expedite processing. So I don't know if anyone's ever thought of this idea before. I tried it out once where I was like, I'll just open 2 sessions of EddyPro and try to run them simultaneously. They still only use up 25% of your CPU. A little bit annoying, but if you kind of pull back the hood and query the scripts behind it directly, you can make it use a much larger chunk of your CPU and actually run chunks of data truly in parallel. So depending on how many cores you have access to on a computer, it can process or reduce your processing time by a quarter or more. So the API can also help standardize processing. It removes the sort of room for errors. If you've got a standardized template that you're using for every single iteration, you're only updating the things that need to be updated. The input and output paths, the date range, etc. Everything else can stay the same. The templates can be viewed or modified either in the EddyPro GUI or in a standard text editor. Using a text editor like VS Code, it's really easy to just find quickly the differences between, say, different processing runs. Currently, this works with LiveCore GHG files or Campbell 205 files. I might try to expand that to others down the line. I also will say currently it only works on Windows. I'm going to try to get it to work on Linux. It's mainly just I don't have access to a Mac, so I have tested it on Mac. Most of it should work. The parallelizing part's a little bit trickier. But anyway, this API can help standardize processing, so you know that your data was processed consistently in the same way, or you can set up 4, 5, 6 different processing routines to run different spectral corrections and test them. And if you have access to, say, a remote machine that you don't need to use, you can just let it run continuously. Nobody has to sort of go in and point and click and all that. So this is just a really simple little example of how one might call it from a command line. You can save this as a batch file and schedule with Windows Task Manager to run once a month, look for new data, and et cetera, et cetera. So this API really does two main things. There's a pre-processing module, which reads all the data preemptively. It goes through and inspects the metadata for changes. So if you're working with GHG files, it'll extract the metadata from each GHG file, compare every 30-minute timestamp worth of metadata to look for changes. This is particularly important if you're dealing with, say, a long record for a site that's been operating for a number of years. For instance, in my previous position, I was responsible for reprocessing some data from a Burns Bog eddy current site, which has 9 years of data, has gone through a number of iterations of different sensors, different configurations, different like north, east, west separation between the sonic and the intake for the 7200, for instance. And so that's important if you're trying to, say, apply spectral correction. You want to make sure that you're not grouping data with vastly different site configurations into the same run to generate spectral correction files for what is ostensibly 2 different setups. So this will go through and check all of that and group the data into periods of unique or similar configuration. It can also parse the high frequency data to generate descriptive statistics, which you can use to pre-filter the data to, say, get rid of any time period that you know just isn't worth using. For instance, if the intake on the 7200 is clogged to the extent that your flow rate is really, really low and you're not going to get any usable flux data, you can just not bother processing that faster data to find out. It can also generate dynamic biomet and dynamic metadata files on the fly, sort of as new metadata comes in. And it nobody's talked about this yet, but Rose is going to be talking about it shortly. It integrates in with the biomet.net database framework that we talked about later. So this pre-processing routine reads all the data, sort of applies some rough checks, groups it based on site configurations, and then prepares it to run. Okay. Then the processing routine actually goes ahead and runs EddyPro over whatever your desired time period is. So it takes a standardized EddyPro template file that will then help ensure that your processing is standardized, and it will just append run-specific information, again, like inputs and output paths, date ranges, etc., leaving everything else unchanged so that you know it's consistent. It executes the raw data processing in parallel batches. So it will split up the raw data processing into separate batches, run them continuously until that's been completed, and then synthesize that back together for the final flux correction and calculation, again, on a per group basis, because we wouldn't want to do that when, say, your inlet tube is 1 meter versus 1 meter, 15 centimeters, because something was changed. It would treat those completely separately. And then it can dump all the outputs, the full outputs from EddyPro into binary files as well. So what's next? I said this was a bit of an elevator pitch. This project is still under development. So I don't have a lot in the way of documentation yet, but it'll be up and available in the coming weeks. But if anybody's interested in trying it out, they can go to this repo here and clone it. And I'm looking for people who might be interested in beta testing it. So if you're interested in trying this out, you can reach me by email there, or you can follow the repo on GitHub and find it that way. I'll just go ahead and paste the link into the chat for anyone who's interested. So that's my spiel. I don't think that full link went through, so I'll do that again.
Yeah, I went through.
Okay. Cool. All right. Yeah. Thank you.
All right, thanks, June. Yeah, so if anyone wants to get in touch with June, you can reach out to them directly, and check out the GitHub page there. And yeah, we've been testing it at a number of sites and it's pretty powerful, so. All right, so moving